I went immediately to your YouTube channel, Dave's Armoury, and I was blown away by your creativity, your execution.
I looked a lot more at how to actually train an AI, how to record and label data, and how to use that data to actually do the training. I don't really have a process for coming up with videos. I sort of just see something and think that an arm or something could do that pretty well, and then try to figure out what sort of technology I can highlight while doing it.
Dave, welcome to the Super Data Science Podcast. It's awesome to have you here. Where in the world are you calling in from?
I'm in Canada, just outside of Waterloo, which is a small town just outside of Toronto.
Well, as it happens, I know Waterloo very well because I went to high school and undergrad in Waterloo, Ontario. And I learned in talking to you just before we started filming that you actually live in a very small town outside of Waterloo. So small, I counted the streets on Google Maps as we were talking. There were 12 of them. Mm-hmm. And they're all about a block or two long.
Yeah, very, very small.
And so I wasn't embarrassed after I saw how small it was that I hadn't heard of this town. But love that area. People in Waterloo region are so nice. When I come home from New York, I'm at ease around everyone. Everyone seems to be happy. Everyone wants to make your day easier.
They're very nice, but they're terrible drivers in our area. It's just the worst drivers.
Oh man. But the niceness counts for a lot. I'll forgive them on the driving. So I was introduced to you by a mutual friend of ours, Graham McCormick, who is the corporate engagement officer at Wilfrid Laurier University, my undergraduate alma mater. And when he introduced us over email, I went immediately to your YouTube channel, Dave's Armoury, and I was blown away by your creativity, your execution. I instantly replied and was like, yes, we've got to get Dave on the Super Data Science Podcast right away. People are going to love to hear about what he's working on. So your YouTube channel has 10,000 subscribers, and they come to see your incredible videos with a huge amount of technical detail from hardware aspects, from software aspects on building AI-powered robots. Mm-hmm. And so we're going to talk about a bunch of these in detail, but it's things like a Rubik's Cube solving robot, a weed exterminating robot that uses a flamethrower to get rid of the weeds, a robot that brings you cold beer on demand, and one that races against your daughter to build a robot unicorn out of Lego. I mean, there's just such a diversity of ideas. Can't wait to get inside of your brain. So let's start with one of these robots that I was just watching the video about, and this is actually, at time of recording, your most popular video. Mm-hmm. Is a cornhole playing robot. So for our listeners outside of North America, cornhole is a game where you have these little like sandbags. I guess they're supposed to be full with corn. And you throw them a short distance, like 10 or 15 feet, into a little hole in a wood board. And that's cornhole. So you have typically teams of two. Beanbag toss, exactly. Mm-hmm. You're just trying to get a little beanbag into a hole at a not arduous distance. It's very popular at weddings. It's a popular drinking game.
Yeah, you do not have to be sober to play.
Probably, almost nobody sober does play. Though I learned a lot about it in your video about the cornhole playing robot, so that there's a professional league. I wonder if they drink.
Yeah, there's a whole league for it. It's crazy.
The American Cornhole League, I guess.
Yeah.
So I absolutely love this video, and it's a good example of the level of detail that you go into in all of your videos, I imagine. So you start off by explaining the cornhole game, and then you start off by getting a robot to cut you the boards that you need to play cornhole. And it's the same robot, Susan,
Mhm.
that also later is your teammate in a cornhole game.
Yeah.
So I thought that was cool in and of itself. So tell us about it. So first you start off by, so you program it to cut the holes into the wood boards.
Mhm.
How do you do that?
So a lot of arms are used in manufacturing. So cutting something like wood is pretty easy to do, or something like aluminum. So I like to show the arms doing common things, like common arm things for the industrial audience. But at the same time, arms are super flexible, so there is a ton of room for arms to grow into, or well, robots in general, to grow into a ton of different areas that they're not commonly used in. So once Susan's done cutting the boards, I clean them up and turn them into cornhole boards. But then using a Jetson, which is basically if a video card and a Raspberry Pi had a baby. So using the Jetson to be able to use OpenCV to be able to find the hole in the cornhole board, no matter where it is in front of it, and then always throw the beanbag perfectly every time to just drain shots.
Awesome. So OpenCV,
Mhm.
that is a software library. You can use it in Python
Yep.
to perform. So the CV in that stands for computer vision. So it's
Mhm.
an open computer vision library. And so you used it to, did you have to do any training with a neural network, or it kind
So,
of just worked?
So not
Yeah.
for OpenCV. So OpenCV is visual processing. So you can pick out like specific colors or shapes or regions. You can do processing on the video or on the
Cool.
frames themselves as they're coming in from the video. So none of that was using AI. That's more, I don't want to say traditional kind of programming, but it's more scripting language, more less AI in training.
Cool. But it still takes advantage of, yeah, this computer vision library that is
Yeah, so it
common.
still
Yeah.
uses CUDA and GPU to do parallel processing really fast, which is why you need something like a Jetson or a video card to be able to do real time work with it.
Got it. Got it. Got it. Yeah. So CUDA, for listeners who don't know it, a popular programming language for programming graphics processing units, and graphics processing units, or GPUs,
Mhm.
which were originally primarily used to render graphics in computers.
Mhm.
So if you're playing a 3D video game, or you're editing video footage on your computer, you need graphics cards to do that work efficiently. But that same kind of computation, these simple linear algebra operations that happen to render those 3D graphics, are the same kinds of mathematical operations that we need to train neural networks, including neural networks that we use for machine vision, like convolutional neural networks. And so, yes, you can parallelize computation in real time, like you're saying,
Mhm.
on GPUs, and like the Jetson that you just mentioned that I had never even heard of before. So it's kind of like a lightweight, low cost, relatively piece of hardware that you can just put right on the robot and in
Mhm.
real time be doing computer vision.
Mhm.
Cool.
Yeah.
Wow. Um, so you basically, you use OpenCV and the Jetson on Susan, this robot arm,
Mhm.
and you then you then modeled the physics of, okay, you detect where the hole is with
Mhm.
OpenCV, and then you say, okay, that tells me how far away the hole is, and then you programmed in the physics, the kind of trajectory that the bag would need to take,
Mhm.
and Susan just executes that for you. It
Yeah.
seems it seems really hard to me.
Well, something it's like grade 12 physics, or probably grade 10, where it's acceleration and velocity and all of those normal things where you get the trajectory of the bag.
Mhm.
And the arm itself, because it's an arm, can do really repeatable, really accurate motions over and over again. So as long as you can tell the arm exactly the motion that it needs the bag to do, or it needs the end of the arm to do, then you should just be draining shots, as long as you can figure out where it needs to go.
Cool. This episode is brought to you by Super Data Science, our online membership platform for learning data science at any level. Yes, the platform is called Super Data Science. It's the namesake of this very podcast. In the platform, you'll discover all of our 50+ courses, which together provide over 300 hours of content, with new courses being added on average once per month. All of that and more you get as part of your membership at Super Data Science. So don't hold off, sign up today at www.superdatascience.com. Secure your membership and take your data science skills to the next level. Nice. So then once you had the robot ready to go, you hosted your own little tournament.
Mhm.
And it looks so. Susan was your teammate in this cornhole game. Tell us about it. How did it go?
Well, we won in some of the testing. So you need to load the bag into the end of Susan. Yeah. So once we had the robot all set up, it was Susan and I against James and Ben, and so we were throwing back and forth, and Susan drained every single shot, and then right near the end, James. On the other team, of course, I had him sticking the beanbags in the gripper on Susan, and he deliberately started putting them in the wrong way so that Susan wasn't throwing them consistently anymore. So she started to miss some shots by the end, but we still won.
Oh, nice. And James himself is pretty well known on YouTube. So
yeah, so he's the hacksmith from Hacksmith Industries. I ended up meeting him through a whole other series of events, but he has a large facility, kind of where I live, that has 3-phase 600-volt power, which you need for an arm of that size or bigger. And I don't have that at home because Canada. So I was actually able to put Susan at his shop and be able to do a bunch of work there, which was great. So he does a lot of videos, making like props and real world examples of things that you see in movies, like Marvel, Star Wars, all that kind of stuff.
Cool. Yeah. So I mean, kind of tangential, but that also sounds like a pretty cool channel for our listeners to check out. All right. So we've got the cornhole playing robot. Clearly, you nailed that one. Susan was able to crush your opponents with you. Another really cool video was your shop defense robot. So tell us about that one.
So I have 2 kids. They're 2 and 4 now. I like to try to include them in either videos or just work that I'm doing whenever I can, just to try to teach them stuff. So I've made, but I don't want them in the shop when I'm not there because, saws and hammers and all that stuff. So instead of just locking the door like a normal person, I got an arm and a stereo camera from Z2 from Stereo Labs, and another Jetson to be able to find the kids in front of the robot using AI, and then take a hose and spray them like cats just to keep them away.
Oh, that's great. So in that kind of case, for the machine vision aspect in particular, how did you program that with this one?
So that's 2 different things kind of happening at once. The first one is using an AI that can detect people. So like something like a Coco data set you can use to train that. I didn't actually train that AI. That came with the Z SDK. So the camera, the stereo camera, comes with some example AIs that you can use. So I use that instead of training my own. But then once the video comes in and it finds the person, it then, using the stereo camera, can get a 3D map of the world in front of it, kind of like how your eyes do. So it can take where it found the person, find where they are in that 3D map, and then it knows exactly where that person is in front of the robot, not just they're there or they're not. It knows, they're a meter ahead and slightly to the side. Then once their arm knows where they are, it can point at them with the hose and go to town.
Cool. Well, that's another really cool application. So we got your shop defense robot. Another one that I loved, and it really shows us kind of how your mind works, is you built a weed exterminating robot. So step one, okay, we've got to have some kind of computer vision system so that the robot can detect where weeds are on the grass. But then
So that
You're
had an arm that has a stereo camera built into the end of it. So
wow.
kind of like the Z, but it's all together.
Mhm.
Um, so I put that on a mobile robot, which is basically a tank, and then a big propane tank and a flamethrower. So for
That's
that, in each
that's the
video, I
that's your
try to kind of
solution.
highlight a specific piece of technology to try to cover it all in detail in a single video. No one would ever watch them.
Right.
But so in that one, I looked a lot more at how to actually train an AI, how to label, how to record and label data, and
Oh.
how to use that data to actually do the training. So in that one, I, recorded a quick video of my lawn. I segmented out the individual weeds, then trained a network
Wow.
on Google Collaboratory, which
Mhm.
is
Yep.
it's a Jupyter notebook, but in Google, and they have free access to GPUs. So you can be doing a lot of this AI training without needing to maintain or buy any of your own hardware, which was awesome.
Yeah,
So I
I love
focused a lot
Colab.
on that.
I use Colab for all of my online teaching because
Mhm.
it's so easy for me to just say, "Here's the URL, let's get going." They
Yeah,
don't have to install anything.
well, exactly.
Um,
So
that's
I'd
cool.
drive the robot around, it would point the camera at the ground, and if it saw a weed, if the AI detected a weed, then it would turn the flamethrower on and burn it right out of the yard. It was very therapeutic for me. Um, a lot of the weeds actually came back through the dead spots. So there would just be a dead spot in
Wow.
the lawn with a weed in the middle, which felt pretty bad, but just watching it happen felt good for that brief moment.
Oh, that's funny. And, yeah, and then if the shop defense robot, if spraying water at your kids doesn't work well enough, you've always got the flamethrower available.
Absolutely.
Alright, so those are good ones. Another one I loved is the pumpkin carving robot. So at the time of filming, we've just finished Halloween.
Mhm.
So this pumpkin carving robot, yeah, I guess that could also kind of work as a shop defense robot. You put a serrated knife
Yeah.
on
There's
the end of the robot arm.
there's a couple different ways that you can obviously cut things. So in that video, I used a knife, which is not a good way to be cutting things with a robot, and a Dremel, which you could do like fine details with the Dremel, but it's not as stabby horror-y as a robot with a blade.
So what's a typical way that you would use? There would be some kind of saw, like a
Like to cut a pumpkin.
well, I mean, yeah. So if you're so for example, when you cut the cornhole boards,
Mhm.
what do you use there in the robot arm? So like you said that a knife and the stabbing action is like not a great use of a robot arm. So what would you
Mhm.
typically use?
Well, normally you'd use some kind of a spindle, right? A router or a spindle is basically like a drill, sort of. It just
Got
a
it.
bit. It just spins it, and then the robot moves it around, and the spinning bit actually does the cutting. There are
Got it.
lots
Got
of
it. Got it.
cases though where you would use something like a knife. Ultrasonic cutting is a big one in like the plastics industry, like just trimming thermoform plastics or anything vacuum formed like car mats. So it's a little blade
Oh.
that stabs in and out like 10,000 times a second. And you can just
Oh.
rip around because the arm can position it at any angle. So you can get lots of fine details around objects.
Wow, that's cool. All right, but that wasn't our scenario here. You've just got a
Yeah.
pumpkin,
A
but you're like,
pumpkin.
so let
Yeah. And a knife I found at Value Village that I sharpened so much that it was too sharp.
nice. And for our listeners outside Canada, Value Village is a chain of thrift stores.
Mhm.
So you can bring anything to Value Village. Well, not anything, but you bring used clothing, I guess,
Mhm.
used knives,
Yeah.
household stuff, and then other people can go and buy it,
Mhm.
typically very cheaply. So yeah, so you got your Value Village knife, sharpen it up,
Is
and
Value Village
then
like a Canadian only thing?
I don't know. I don't. I must admit, since I've been in New York, I haven't done much thrift shopping. We do have Goodwills. I see Goodwills around, but I
Okay.
haven't seen a Value Village. I think it might be Canadian.
Okay. Yeah.
So,
Goodwill. Same thing.
yeah. Um. So yeah. All right. So then, what was tricky about that? I guess is that similar to the kind of scenario? Do you have to do any machine vision to like detect where the pumpkin is? or do you kind of, yeah?
So I didn't actually use any sort of AI or machine vision for that. That was
Yeah.
more offline programming. So programming it in your computer without the robot, which makes the robot usually more accurate and more productive because you're not taking the machine down to program it.
Cool.
Or for that, actually, I did a bunch of manual programming with the UR I was using, like the universal robot arm that I was using. You can grab it and move it around, so it has hand guiding built in. So instead of just using the controller, you could physically grab the robot and position it where you want it. So that's a good way for anyone who's getting into robotics, or the newer users. It's a lot easier for you just to say robot go here, and you can grab the robot and move it.
Cool. I am learning so much. I suspect our listeners are as well. All right. So just a few more. I could probably go through all of your videos, and this would be super interesting. But we're just trying to pick some of the most different, most interesting videos. So another one was a Rubik's Cube solving robot.
Mhm.
Whoa.
Yeah.
That's something. There's been, in the last couple of years, there have been big papers in the industry from, like, big research outfits. I think like OpenAI had a
Mhm.
big paper about a Rubik's Cube solving robot. And so you did it too.
Yeah. Well, so the algorithm for solving it, I just used a Python library that already existed. I didn't write that myself. But being able to use the arm with just a single arm and no gripper, actually, to just be able to pick up and reorient the arm or reorient the cube and solve it by hand. I raced it. I won, but
Oh man,
that
nice work,
was
Dave.
also some really inefficient programming on my part. So it's kind of cheating.
That's good. You're like, I'm definitely going to win this race.
Yeah.
So better put. So yeah, that's different from the situation where you're playing cornhole, where you knew that Susan was going to be on your own team.
Yeah. So I wanted her to do really well,
Exactly.
whereas it was me against Herman. Herman was the UR that I was using for that. Yeah, I didn't really worry about programming it super efficiently. It's more, yeah. So again, in each video, I try to show kind of a
Yeah.
different benefit to arms or a different way you can do it. And being able to have the arm literally pick up the cube, look at it, figure out a solution, and then do it, that's more beneficial, or that's more the benefit that I was trying to show, that you could put functionally almost anything in front of the robot and it can figure out a new path, a new
Yeah.
solution to that problem versus something like hard automation, which only does one thing.
Yeah, super cool. Yeah, and I feel like I'm starting to get familiar with your industry terminology. Terms like UR, when you throw them out there, I know exactly what you mean. A universal robot arm. Cool. All right. So uh, another one, you got two robots, two different videos that could work with Lego. So one of them created Lego art. It created
Mhm.
uh, not a painting because it was Lego art, but a something that looks like a painting of
Yeah.
Darth Vader.
Mhm. So
Um,
yeah, Lego released an art series where they got ones of the Beatles, they've got, I think, a Marvel one, they've got some Star Wars ones. Those are it's really repetitive. So it's literally pick up a little pip and stick it on, I think, a few thousand times, which
oh
is
wow.
up which is perfect for arms, just doing a simple task over and over and over again. But to program that manually would be a nightmare. So to be able to, I just programmed it with a simple Python script, which is on GitHub, if anyone's curious.
Oh, cool. Yeah, great. We'll be sure to include that in the show notes. Um, and all right. So then you said that it was simple to have this highly repetitive task, and okay, that makes sense to me. So placing these
Mhm.
pips the right color in the right place. Um, but something that sounds more complicated then is doing something like building a robot unicorn, but you did have a robot arm do that and race against your daughter. So how'd that
Yes.
go?
Herman won. My kid
Oh.
lost publicly on the internet. I mean, it's a real strength building kind of thing. It's a real character moment for her.
Mhm.
That one was using a gripper and a force torque sensor. So actually being able to grab the piece, know when it grabbed the piece or if it missed, and then when it's putting in, push with a certain force in certain directions. Because just having the pieces snap together is surprisingly hard with Lego. It's easy to do if you're doing it by hand, but if you're trying to do it blind and stick pieces together, you need to be able to feel the feedback when the pieces actually engage with one
Right.
another.
Wow. Yeah. So it sounds like that might have been the focus of that video,
Yeah.
explaining that part. Yeah.
Mhm.
Cool. All right. And then just one last robot to round things off. This is one really after my heart because I don't drink very much these days, but I love beer, Dave.
Mm.
It is
Feel
the
you.
only, people often talk about wine in a lot of detail. People seem to know a lot about wine. I don't know anything about wine,
Mhm.
but I know a lot about beer. And so you have a robot that can bring you cold beer on demand.
Mhm.
Wow.
Yeah. So that's using a mobile robot from ClearPath Robotics. So it can drive around on its own, and it has a lidar on it, which is a laser that spins around and it can see the world around it. Using that, it can make a map of my house, drive around my house on its own. I
Wow.
paired that with Google Assistant or Google Home, so I could say, hey Google, bring me a beer. It would wake up the robot, drive the robot to the fridge. Then the robot would use an arm with a gripper, open the fridge, pull out a beer, close the fridge, and drive it to wherever I told it to go in the house.
Wow. That's cool. All right. So uh, there's 8 examples for you listeners of some of the incredibly diverse and creative different kinds of robots that Dave has built. You can get all of those on the Dave's Armory YouTube channel. So, Dave, how do you come up with these ideas? Uh, like, do you have a process, or do you're just like, I'm annoyed by the weeds on my lawn. I'm gonna get rid of them. I'm gonna find a way to do it with a robot.
I don't really have a process for coming up with videos. I sort of just see something and think that an arm or something could do that
Right, right,
pretty
right.
well, and then try to figure
Cool.
out what sort of technology I can highlight while doing it. Again, trying to sort of teach people, but at the same time, I do have sort of just a grid for thinking of what videos I should actually do. Because coming up with ideas is
Oh,
not so much the problem; it's
right,
weeding out all the bad ones.
right.
So trying to find videos that are relatable, because I want people to not be afraid of robots. I want them to understand that they have a place, they have benefits and challenges. They're not great for everything. They're good for some other stuff.
Don't
Um,
be afraid of my stabbing, flame throwing robots. Nothing to be
yes,
afraid
don't. They're friendly. You
of.
want them to trust you. Um, so I try to find videos that are somewhat relatable, because I want people to be engaged and interested and comfortable with robots. But I also want the video to have some sort of challenge to it, and be using a robot in a way that's not a common use, right? You can go on YouTube and you can see, robots building cars, or robots welding, or robots assembling, or any of those are very common. And there's lots of examples of that. But I want to show robots doing things in very uncommon spaces. For example, yeah, beer delivery, or, weed murdering.
Nice, and it opens my mind up. I kind of and I'm later in the episode. I'm going to kind of ask you about what kind of education someone needs to be able to build some of these kinds of robots, and it's going to be interesting to learn about that. But I kind of you meeting you and seeing your YouTube channel, it makes me believe that I could be creative with robots. There's things I could do. Um, whereas previously, like I kind of thought, as you say, when I see a welding robot or a car building robot, that seems like something you know unapproachable to me for some reason. But because these are tangible, kind of everyday applications of kinds of robots that would be cool in my life, yeah, it is your. I think I mean your YouTube channel has certainly had that effect on me, so I'm sure it has on other people as well. So I think
That's
you're
great to hear.
yeah.
I'm glad.
Yeah. All right, Dave. So, dare I ask, what are some of the robots that we might see on your YouTube channel in the future?
Um, so from a hardware standpoint, I'm still doing a bunch of work with Kuka. So I have another Kuka actually coming soon, I hope.
What was Kuka used for?
So
When you
Kuka
said that?
was Susan. So that was a
Oh, Susan. Right.
KR20, which had a big controller that I couldn't run at home. So I think the one that is coming next is either going to be a KR6 or a KR10. So like a 6 or 10 kilogram payload. It's more of a desk size robot that you can run on
Right.
just normal 110. Um, so I'm actually working on, and depending when this video or this podcast comes out, I may have already released this video, or I might not if I didn't get to it. I'm working on a video about how to make an AI for a small arm that will find my cat and then use a laser pointer to play with my cat. So that's
Oh,
like
that's great.
AI and a stereo camera and ROS and ARMS and inverse kinematics, kind of all that stuff.
Nice.
But again, everyone plays with their cat, right?
Yeah.
So that's coming. I want to make an autonomous lawnmower here using not a lawnmower, of course. And because Canada, I also want to try to make a robotic snowblower so I can get out of my
Right.
driveway. But
Right.
we'll see if I get to that.
Wow, those are a lot of cool ideas, and they all sound like classic Dave's Armory.
Mhm.
Brilliant. So, Dave's Armory, the YouTube channel, is not the only application of Dave's Armory. You
Mhm.
also have a consulting business
Mhm.
um, of the same name, and so tell us a bit about that, about like what you do with the consulting business, how you help people out.
Sure. So I started posting these videos on YouTube, evenings and weekends, whenever I would get free time, um, as limited as that is.
Mhm.
But a bunch of people have seen those videos and reached out to me through Instagram or Twitter or wherever, or been local businesses in the area and said, "Oh, well, I've been thinking about how to improve our manufacturing process, or I've been thinking about how would I make a robot that drives around and does X." And so I end up doing a lot of consulting on the side for helping companies develop new technologies or develop new robots that fit with their current business or wherever their business is planning on going,
Mhm.
or helping companies try to see where they could be using automation in their manufacturing, whether it's packaging or something like that, or just explaining what I would consider to be very simple things about robots that I'm seeing is not commonly known.
Yeah,
For
I
example,
bet.
integrators. Right? A robot integrator is a company that will look at your facility, look what you need to do, then pick which robots and hardware and safety and all of that you need. They put together a custom system for you and deliver it, and then that works in your facility.
Mm.
To me, I thought that was everyone knew about robot integrators. Apparently, that's not true. Apparently,
It's
surprisingly, unless
news
you've
to me.
worked with a robot integrator, surprisingly few people
Right.
know that these companies exist.
Super cool. All right. So, are there any like, is there a particular project or two that you'd be able to share that could be interesting for us?
I'm working on a project right now to make an autonomous lawnmower, a self-driving lawnmower. So, in one of my past lives, I did mobile robotics using ROS, which is a framework for building robot software. It has tons
Mm.
of libraries, tons of tutorials. I would absolutely recommend it for anyone who's looking to get into
Oh, cool.
robotics or at
Ross.
least poke around or try stuff. It's ROS, Robot Operating System, not
Oh,
an
cool.
operating system. Um, but so using some software kind of like that to be able to take an electric mower and have it drive itself around and mow a lawn for you.
Mm. Cool. Yeah, that sounds very much like, yeah, I mean, that sounds like it could be one of your YouTube videos. So that's
Mhm.
cool that exactly the kind of stuff that you share with the world to educate us, and maybe spark our own creativity about what we could be doing with robots in the real world. you're also being able to directly leverage that to be making a real impact in the industry. It's cool. All right, so Dave, we've talked about some of the kinds of machine learning software libraries that you've used. You've talked about Python, you've talked about OpenCV, you've talked about GitHub, you've talked about Robot OS. Are there any other particular tools, I guess particularly maybe software or data science related tools that might interest our listeners?
Well, we talked about Collaboratory, which is
Oh
awesome.
yeah, we've been playing that.
There's
Yeah.
a website called RoboFlow that I actually found, I don't know, a couple months ago. I used it in the weed killer video. That is actually a great website for doing um, like you feed it in images, you can mark them out where they are, you can set up your different classes, and it has built-in augmentation too. So you can just say generate, 4 times as many versions of pictures, and it will just take them,
Right.
increase and decrease the contrast, do all that stuff.
Right. Right.
And you can
Right.
do that a lot of different ways, but it's just super easy on that. Um, Jetson would probably be actually my biggest recommendation for something like this. You can
Hmm.
get a
Hmm.
Jetson Nano for like $100, I think. And it's a full-on little computer. It has I/O, it has CUDA cores. You can use it for machine learning. It's low power, it's cheap. So that's an awesome way to start with any sort of this stuff. I'd also said ROS, which is, again, there's a simulation. So anyone who wants to do robotics but doesn't have a robot, which is, I would assume, most people, you can run simulations in it, so you can functionally have a robot without needing the hardware or really needing one. That's a great way to start.
Awesome. So tell us a bit about how you got started in all this. So, we know about kind of where you are now. You
Mhm.
you have this flourishing YouTube channel, you have this consulting business. How did you end up here?
So I went to university for engineering. Well, between semesters in university, I worked at a robot integrator. So just doing wiring and
Mm,
painting and not so much software, but a lot more of the kind of the hardware install stuff. I went from there to doing offline programming software for robots. So that's having a basic simulation in your computer, that's creating programs for the robot directly from the CAD model of whatever part you want to create, and then taking that simulation, that data, and having a real world robot run it. It's faster to program. It makes your robot far more efficient. You can start running one-off parts on your robot instead of needing 5,000 parts before it's worthwhile. That got me very close with a lot of the robot manufacturers around. So I would go on site because I had to troubleshoot and work through a lot of the hardware, understand a lot of the hardware and the software inside of the robot
mhm,
before I could make any of that work. And that was kind of
mhm,
the bedrock for a lot of where I started from there. Then I went into mobile robotics, which is ROS and AI. It's instead of making a program then telling the robot to run it, it's a much tighter connection between the two, where you're receiving sensor data live, you're processing it, you're coming up with solutions, answers, and then having driving the hardware directly. So that's usually a closed loop, live control of the robot, and that got me into a lot of different AI stuff. I did a bunch of wiring and software and that kind of stuff in school. So, sort of a melding of all of those different things sort of got me here, which is also sort of a melding of a whole bunch of different things that turns into fire robots and kid defense.
Cool. Well, that was a really great summary. Following on from that, what would you recommend to somebody who wants to get started out building their own AI robots? I mean, you already talked about something. So you talked about Ross, you talked about RoboFlow, Jetson Nano, obviously those kinds of things. But I mean, in terms of an education, you have an engineering background. Does somebody need an engineering background? What I guess probably a lot of our listeners, they already have some familiarity with programming. So,
Mhm.
if you already have a little bit of programming experience, what should you do next?
So in my videos, I use different cameras, different different power supplies, different programming languages, different networking stuff, different arms, different AIs. There's a ton of different pieces that can all come together in a robot system. So to work, you don't have to know robot arms to have a significant input in like a shop defense robot. You wouldn't need to necessarily know arms to do a lot of that as long as you can do AI or you know cameras really well or you understand ROS. So, I mean, normally in most cases, as like an employee in the company, you wouldn't be doing all 10 pieces of this. You'd be doing maybe the
Right.
AI and the vision or
Right.
maybe the arm control. So I would say don't worry about trying to do all of it. Pick a piece that you really like. If you really like AI, that is a huge stepping stone to making a robot smarter. Or if you really like wiring, learn how to do wiring and some basic control stuff so you can make grippers or different attachments to arms or different control systems that communicate between devices. And you can again use that to make robots smarter or to make your own robots down the road with motors and controllers and wiring and encoders and stuff. I know that was a
Cool.
really long-winded answer of just
No.
kind of do what you like, and
No. Yeah.
it's a step in the right direction.
Dave, it was a beautiful answer. I was actually like
Oh,
in awe the entire time you were saying
I'd
that. It
like to
was
thank my
perfect.
mom, my dad, the academy.
um, cool. All right. So, Dave, do you have some master plan? With Dave's Armory, we've got snow blowing robots coming out maybe soon. I mean, what's the like big vision, if any?
I mean, my long-term goal with all of this, I think, would be for it to become self-sustaining enough where I can wake up in the morning, go into my shop, dick around with robots all day, and then go home. Just the freedom to be able to any project I want to make, regardless of whether I think it's going to be, good on YouTube or not, or regardless of whether I have a specific project. Just that the freedom to be able to make whatever I want with whatever hardware I have. I like that flexibility.
Cool. That's an awesome dream. And I believe you can achieve it.
And,
You
and beer.
are, yeah. I need a whole army of beer retrieving robots.
Mhm.
And step 1, army of beer retrieving robots. Step 2, question mark.
Yeah,
Step 3, enormous profits.
yeah. World domination.
Exactly. Um, cool. So, all right. So here's kind of a big one, kind of a big question. It's one of my favorite questions to ask on the show, but I don't actually ask it all that often. It's kind of like something when I save for guests that I think are going to have a really interesting take on this. So you are working in a field that changes rapidly.
Mhm.
You know, probably every 5 years, it's kind of a completely different landscape in terms of what's available for hardware, what's available for software, what you can do, what applications are possible. So there are these various trends, these exponential trends. Each one is exponential, and they combine together to mean that the pace of technology is moving extremely fast every year. So we've got data storage is extremely cheap and always getting cheaper. Compute is cheap. You're talking about these Jetson Nanos with GPUs on them for $100 that don't take very much power. I mean, amazing. There's more and more sensors everywhere, and those are getting cheaper. You've got these stereo sensors, like we've got tons of interconnectivity, internet bandwidth. People are sharing their innovations. People are committing to GitHub repositories and uploading YouTube videos like you are about how to be doing various aspects from a software aspect, training a neural network all the way through to the wiring, the robotics. we can learn about so much of this stuff online. So with all of these different exponential trends all happening, what excites you about what might happen in our lifetime with, say, AI robotics, or in your kid's lifetime?
I think oddly enough, the one thing I think I'm most excited about is self-driving cars. I mean, they are robots in kind of the purest sense. I mean, they're hidden inside a car, but they are still autonomous vehicles. And I can't wait for traffic jams to be less and for me not to have to drive places.
That ties back to the very beginning, talking about Waterloo and how people are bad drivers.
Yeah, I am very excited to have that problem just sort of take care of itself.
It's the thing we started at the very beginning of the episode. We need to get the drivers out of Waterloo.
Yeah, it's funny. I used to travel a lot for a previous job, and always coming back to KW. It's like just terrible drivers here. No matter where I went, always the worst here.
KW, for our listeners, is Kitchener-Waterloo, which is two separate cities that have both grown very large and now just overlap a lot. So
they just melded into one.
Yeah.
I'm very excited for something like self-driving cars, but I don't know where any of this is going. Like you said, we keep getting more compute and more storage and more everything. But I mean, what's the next big thing? I have no idea.
Yeah,
and I hope to be part of it, whatever it is.
Robots. Wow, yeah, I think you are. Whatever it is, you are already a part of it. All right, that's awesome, Dave. Do you have a book recommendation for us by chance?
The last series I read was the Bobiverse. You read that?
The Bobiverse?
Bobiverse, yeah. It's about a guy who dies and is reborn again in the body of a robot. And so he has, like, it's his consciousness, but with control of robotic hardware, and he becomes a spaceship. It's a very good book series. I think there's 3 of them. Quite enjoyed it.
Cool. Well, that is an awesome recommendation for given the topic of this podcast. Nice work. Sometimes people go completely, you never know what book people are going to talk about, but your book was very much on topic. So that's cool. So in terms of following you, obviously the Dave's Armoury YouTube channel is a go-to spot. I cannot implore the listener more. If you are vaguely interested in how robots work, how you can be putting machine learning algorithms into robots and be doing meaningful work with it, Dave's videos are amazing for explaining in a surprising amount of granular detail how you can be doing it yourself. So I highly recommend Dave's Armoury YouTube channel. How else should people follow you or get in touch?
Either that or Instagram. I have an account on there. It's Dave's Armoury with a U because Canada.
Yeah, the U in Armoury. Yep. Cool. Well, all right. We'll be sure to include those in the show notes. Dave, thank you so much for taking the time to be with us. I learned so much, and I'm sure our listeners did too. Hopefully we'll have you on again soon sometime so you can tell us all about your new armies of robots that have developed in the meantime.
Yeah, thanks for having me. It was great to be here. I'll be back.
What a fun and utterly mad scientist, or should I say engineer, Dave is. I love his creativity, and I can't wait to see what robots he conjures up next. In today's episode, Dave greatly expanded my understanding of robotics. I hope he did for yours too. He detailed his mission to get people into robotics by publishing entertaining but nevertheless highly technically informative content on his Dave's Armoury YouTube channel. He talked about hardware such as universal robot arms, ClearPath mobile robots, Z2 stereo cameras, and Jetson Nano GPUs. He also talked about software such as the OpenCV computer vision library, the ROS robot operating system, RoboFlow for operationalizing machine vision algorithms in robots, and Google Colab for training deep learning models freely and easily in the cloud. He also talked about robotic integrators that provide custom industrial robotics solutions, and that if you'd like to get into the AI robotics world yourself, you shouldn't try to become an expert in everything at once, but perhaps focus on the AI modeling aspect in particular, especially if that's already your strong suit. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Dave's YouTube channel and Instagram profile, as well as my own social media profiles at www.superdatascience.com/529. That's www.superdatascience.com/529. If you enjoyed this episode, I'd greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel. I also encourage you to let me know your thoughts on this episode directly by adding me on LinkedIn or Twitter and then tagging me in a post about it. Your feedback is invaluable for helping us shape future episodes of the show. All right, thanks to Ivana, Mario, Jaime, JP, and Kirill on the Super Data Science team for managing and producing another fun and informative episode for us today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.